Um, is it working? Can you hear me at the back? No? Okay, so hello everyone, I'm Sanket. I'm co-founder of Campus Hash. So I'm co-founder of Campus Hash. We do workshops, hackathons, and events in colleges across the country. Our startup, Campus Hash, has been the workshops partner for PyCon India. We celebrated Python 1 together. We did free workshops in Python in over 10 colleges across the country from our side. So today I'm going to be talking about packaging and distribution of your Python code. So it's going to be a very beginner talk. I'm not going to dive much deeper. So please, don't ask me complicated questions. So yeah. So packaging and distribution and distributing your Python code. So how many people here have written Python modules of their own? Anyone? Oh my God. So I'm going to get a lot of questions. So let's start. So you have your module ready. What do you do now? What do we do? We go to the cheese shop. So the cheese shop is, we call PyPI, the Python package index, as the cheese shop. So yeah. So what are we going to cover in this session? Your module will be easily installable using pip, easy install. It can be specified as a dependency for other packages, and it will have proper tests included. I mean, it totally depends on you. I'm not going to show you how to write tests here. It will have proper documentation. That again depends entirely on you. And yeah, this thing I can guarantee it will make the world a better place. So, or you get your money back. So let's see, how do we lay out a basic package? So this is kind of a generalized form of your package. So we generally name our package in camel case. So suppose I've created this hypothetical module called Moon Grabber. So this is basically my module, and for the package I've used camel case. So this is the basic convention. I mean, you don't have to adhere to it, but it's a nice practice. And then we have these directories, which is normally people put in packages. So we'll cover these in details. So let's see. We have a bin, and then we have these files, changes.txt, which basically contain the changes which you have made over releases to your package. We have docs, which you can put. I mean, you can put docs here. Then license. So you can just copy paste your favorite license. Manifest.in. We'll just see what these files do. In fact. So yeah. So bin contains any scripts which use the package, which use a package that could be helpful for the users. So these can contain command line scripts, or for some configuration or something like that, which basically make use of your package. And then the changes.txt is the list of changes to your module in your successive versions of your releases. So the general format for changes is like this. So you put your version, then put a comma, date, and then whatever changes you have made, you can do it like this. And you can make it a text file. And the docs contain the documentation for your package. License, just copy paste. So manifest.in, this is an important file. So the manifest.in specifies the extra files which you want to ship with your package, apart from, of course, your basic Python module. So it specifies the extra files. So suppose you have some data files which are required by your package. Suppose you're building something which has some which requires some data which you ship with your module. So you can have that data in JSON format. So you can include it like this. So a manifest.in file is nothing but a list of commands. These commands can be recursive include. So you just give a command and then a pattern. Okay, and this is how you can include more files. Recursive include traverses a directory which you specify recursively, and depending on the pattern, it included those files. And then we have, if you dig into the documentation, there are some other commands which you can put. We have a prune, we have a graft command. So when you do a prune and a dictionary, it will basically exclude that dictionary. If you do graft and a dictionary, directory, it will include that directory. So there are so many other commands which you can look at. And then the readme text file, or I think I made some mistake. It should be readme.rst. So RST is the restructured text. This format is used if you write your readme in a restructured text. It will when you upload it to your PyPI index, when you upload it to PyPI, so PyPI will take this and create the home page for you, using this on the home page. So it creates it really nice. So this is kind of like Markdown, if you have heard of it. So this is very similar to Markdown, but there are some differences. So you can dig into restructured text RST and find out. And then we have a setup script, as we have seen here. So the setup.py script is basically where all the action happens in packaging. So it contains in your project folder. So this is your module, and it contains in the project root. So this is where all the magic happens. So we'll just see what setup.py contains. So we are going to use here distutils. Distutils is the standard module for distribution in Python. The setup method is available at distutils.core. So these are the parameters which you give to your setup function, and that's how you package your code. So you can have the name. So that is the name of the package. Then you have a version, author email. Then you can have some other parameters like maintainer email, whoever is going to maintain your code, something like that. Then packages, scripts. So these are some parameters which we are going to discuss in further, which we will see what these do. And then we have install requires as a parameter, which is used to specify dependencies to your package. Okay, so dependencies can be specified using these comparisons. These logical operators. So it says Django greater than or equal to 1.1.1. So your package needs a Django version which is more than 1.1.1. If you want to obsolete a requirement, if you want to say that now my module does not need this particular package anymore, so you can do some package name not equal to the version number, something like that. So this is the way you can specify requirements to your package. And yes, so this is how we create a source distribution. Or source distribution is basically you distribute your source code. Okay, when your project is open source, you can use this sdist command. Creates a source distribution for your package. So you can run this on in your root package root directory. Python setup.py is your where all the action happens, and then sdist as a command. So this will create a manifest file. Okay, so we had specified a manifest.in file, but when you do sdist, this will create a manifest file, which is basically a list of files. If you see, it is a list of files which have been created. What do you say? Distutils maintains this file to keep track of all the files which are present in your package. I'll just show you. So I've created this, and then this file is generated by distutils. It contains all the scripts, all the Python modules in your package, and this is generated by distutils. So you should not edit this. Should you choose to edit it, this should contain all the files which you need to include in your package. So you have to, if you choose to manually edit this file, you should list all the files which you need with proper paths like this in that file. Okay, but that's a bad idea, because you might have so many files and you don't want to do this. So, and yeah, so when you do this, this will create a dist folder. So let's see. So the dist folder contains this file, gzipped file. This is your source distribution. You can upload it to your private repository or somewhere else. And if you choose to upload it to PyPI, this is the file which gets uploaded. Okay. and then yes, after you have done these things, after you have created your distribution, you need to register it to PyPI, of course. So if you have not registered with PyPI, you have to do Python setup.py register. Register is the command. If you have not registered, if you don't have an account at PyPI, when you do this, the command line will show you steps to register yourselves. If you have internet, just please try to do this. If you have created a dummy module or something. So when you do this, you have options where you can log in, you can create a new user, or you can, if you have forgotten your password, then you can resend your email verification. So and if you've been doing this for some time, when you do setup.py register, then if you're already logged in, this will register your package's name with PyPI. Okay, this will register the package's name, upload its metadata, create its web page. It will do all those things, but it won't upload a distribution yet. Okay, so once again, if you have not registered yourself with PyPI, this command allows you to register yourself, and then you can log in. And after that, when you call this, then it will register your project, your package with PyPI. It will register the name, upload the metadata, and create a PyPI web page. Okay, so let's see what a PyPI web page looks like. So this is the web page, the home page that PyPI created for my module Moongrabber, as you see. So when you do this, if I had not uploaded the file, this won't come here. Only these things are done. Only it will generate a web page, a home page, and put the metadata here. But then I uploaded it, so it shows that I have one release uploaded. So yes, and then you can use upload as a command to upload your distribution to PyPI. You should always use this sdist and then upload. It will first create a distribution and then upload it. You should always do this. So yes, and whenever you want to update your package again, you should use this. Okay, so one more thing. So PyPI has this, I think if my internet is working, yeah. So PyPI has this simple protocol. This is basically a web page which contains links to all the packages which are available in PyPI. Okay, so this is a huge web page. So there are, I think currently there are 34,000 modules available at PyPI. So this will contain 34,000 links, more than 34,000 links for all the packages. And your package, or my package called Moongrabber, should be somewhere here. Yeah. So your package will be listed here. And then this, when you click on this, this page will contain links for all the releases which you have made. Okay. So this is my release. So whatever releases you do successively, all your releases can be will be listed here. So you can use this web page somewhere. And yes, you're done. So you have completed packaging. You have created your module. You created a source distribution. You have uploaded to PyPI. And after that, when you do pip install that package's name, or easy install that package's name, that will be installed on your system. So this is what is, that's how you do packaging. But there's something more. Let's dig a bit deeper. We have classifiers. So classifiers are used to provide external metadata, additional metadata. They allow you to explain your project, your package extensively. So we'll see. So classifiers is an argument to the setup function, and the list of classifiers can be found at that URL. Let's see. Yeah. So these are classifiers. If you look at it, can you see it at the back? Is it visible at the back? No. Okay. Now. Okay. So these classifiers are used to explain your package. So say you are still in alpha stage. So classifier as a parameter to the setup function, it is nothing but a list of strings, list of these classifier strings. So you can have as many strings as you want. Suppose you are in beta phase, so you can have this string development status for beta, and then suppose you are building for specifically for Mac OS X, you can do this, and you can specify your framework, intended audience. I mean, you can add your license here. So these classifiers basically allow you to explain your package so well. And then, so we were talking about modules here. Let's see the file. Yes. So if you look at the setup file, I have this parameter to the setup function called packages, and the packages, it takes a list of strings which define the modules which I have. So if you look at the directory structure here, I have this moon grabber package, whatever you want to call it. So if you look at it, it has this moongun.py file, and then it has a test file, a test module. So if you look here, this means this, and this means this. So inside my moon grabber package, I have two modules, and you can specify like that. And sometimes the way you organize your source directory is quite different to the way you want to distribute it. So suppose you're creating a folder called library, and within that you're doing everything, and you don't want to distribute it like something inside library. So what you can do is you can customize it. You can customize it using this parameter packages _dir. So what you do here, it is a dictionary which takes as keys the name which you want to distribute it under, and as values the folder which is intended. So suppose I want to distribute the folder boo as bar. So this is how you do it. An empty string, it means the root directory. An empty string in keys means the root directory. An empty string in values means the current directory. Okay, so this is how you can customize it. And then if you don't want to create packages, if you just want to if you have a utils.py file where you put some nifty functions, if you just want to distribute that, you just can use this py modules, and it takes a list of strings which is individual Python scripts. So you can specify the file names here, the module names here, and yeah, that would be it. And yes, so sometimes you might want to have you might want to write some modules in C or C++, and then distribute it as extension modules. So this function, this parameter ext package, ext modules allow you to do that. And then if you have some library dependencies, if you're using some libraries in your C or C++ application, then you can use this. You can specify the dependencies like this. And yeah, adding some more data. So if you want to add more data to your module, which is critical to your module, you can use package data. This would mean that these pieces of data are critical for the functioning of module. Then with data files, you can include some other not so critical files like images. If you're building a GUI sort of thing, you might want to include some images or something like that. So you can use this. So this is how you can add external data files. And then sometimes you might want to create, you might not want to distribute your source. You want to distribute binaries. So you can create built distributions using setup.py bdist. So using setup.py bdist creates dumb distributions. I mean dumb binary distributions, dumb build distributions. What does a dumb build distribution mean? It means that it's not, what does intelligent distributions mean? The user doesn't have to, go and unzip something and then install. You can directly have, .deb or .rpm, which the user can directly do something with that. So here, you can create archives for specific platforms. Like you can create RPM, you can create a Windows installer, you can create a MSI, but these can be done only on respective platforms. So this is how you can create built distributions. And then sometimes you might not want to specify everything hard coded in your setup.py file, because sometimes you need some parameters to be set by the user who is actually installing your package. So you can have this setup.cfg configuration file in your root directory. What does this do? This takes, how do you specify a setup.cfg file? This here is a command, just as we saw, bdist _rpm or something like that. And after that, these are options. Okay, so you specify the values of these options here. So when you specify a setup.cfg file, it overrides your setup.py file configuration. So if you say I had my name on the setup.py file, and then someone overrode it using set.cfg, this will override it. And then while building your package, you can override this setup.cfg file as well using command line options. So we'll just see how to do that. No, wait, no questions yet. So I don't have a setup.py file right here, but still. So yeah. So this is how I would do it, and then I can do something like this. I can do something like this, and this will build it. So this won't work because I'm using Debian, not using Red Hat. So this is how you can override your setup.cfg using command line. So yeah. So I guess we're very through it. Right? So once again, this is my package. When you build it, when you build a source distribution, it will create a dist folder. Okay, this dist folder will contain your distribution, whatever it is. If you create a built distribution, it will create a build folder. So yeah, and after that you might want to look at. So this was I was just discussing distutils here. You might want to look at setup tools. You might want to look at distribute. There's a new repository coming. There's a new project coming up called Wheel. So these guys are extending distutils. Not really, but these guys are doing a better job than distutils. Yeah. So I guess this is it. I'll take questions now.
Any tips with dealing up with a package that you're using in a different repository while you're developing both?
I'm sorry.
If you're using one package which you've developed in another project, and you're working on both of them at the same time.
Yeah. So you can. So what you want to say is, if I'm getting this correct, you want to specify your one package as a dependency to other package, right?
No, I'm working on both of them at the same time. So while I'm working one, I want to install it in another package.
While you're working on one, you want to install it in another package?
Yeah, in another library, in another project.
So first you have to host it somewhere, right? Either on PyPI or somewhere else.
No, like you can go setup.py develop. So it just creates a symlink in your virtual environment. Is there anything like that?
Okay, I'm not quite sure about that. Yeah, but you should use virtual environment. So I couldn't cover it here. So any more questions?
Hi.
Yeah.
When we create a distribution, the version control will automatically taken care?
I'm sorry?
When we create a distribution, the versioning for the module will automatically be taken care?
No, I'm afraid not. So what you need to do here, if you've seen my setup file, let's look at it once again. So you need to have your versions here. You need to have your version here. So that will basically tell distributors that you're developing this version. So obviously you can mechanize it. You can do it something whenever you do a commit. So you can write some script which can.
But the GG file which we created will automatically.
Yeah, that will automatically do it. Okay. So that depends on the version which you give here. So the GG file will be created automatically. Sure.
So let's consider that over the period, right? You started from version 1.0. Are you able to hear? Okay, you started with version 1.0, then you moved on to 2.0 and so on. So now while moving forward, I don't want that the previous version should exist. So
previous versions should exist.
Yeah. So if that kind of things we have to do, so what is the right place and how should we do that?
What is the right way? Yeah. Okay, so what I feel is personally, you shouldn't do that because you should always support legacy versions. But then if you really want to remove your previous versions, then if you go to PyPI, they'll have a web interface. They allow you to remove some versions from there. You can do that.
Okay, so basically my concern is like even though you develop the 1.0 2.0, right? At the end, when it comes to the customer, right, who is actually deploying it, when I'm using a higher version, I may insist that user should not have the lower version sitting on his disk.
So yes, so you can specify dependencies, right? I guess you're talking about dependencies. So okay, so let's rephrase that question. So you are saying that you have a package, and then you want your user to specify a particular version, not the older version, the newer version. Okay, so install. So whatever package you are using your package in. So some X package you're using your package. So that package has to have this dependency. So you can specify dependencies like that. So if you don't want some version, you can do not equal to the version number. It works like that. Yeah, so if you do an upgrade, it will basically fetch the latest version available. If you just want to install a particular version, you can just pip module name equal to, or you can use a convention like that and the version number. So that will install a particular version of that package. Packaging data files? I'm not. Okay. So as I said, I mean, you can just include that either in your setup file. I'll just show you. Packages data. It was in the slides, I guess. Data, yeah. So you can either use it here, packages data or data files, or you can include it using your manifest.in file. So these things will include those files into your distribution.
Hello. So if my package have got some operating system dependency, like if it is supposed to run on say RHEL 5.9 and above, so where do I include this information in the setup?
So you want to include operating system dependencies,
right?
So one way you can do it, you can either build your stuff for a particular platform. You have options for that. I may not be able to cover it, but you have options for that. The platform for SDist or BDist, there is a platform property platform option which you can use to specify different tiers. And I'm not so sure, but there might be a parameter in the setup file. There is a parameter in the setup file which allows you to have those platform dependencies. There is a parameter. Yes. If you use pip, and so pip is really intelligent, So suppose you have same version for say 5 kind of operating systems, and you're using one kind of operating system and you're doing pip, so pip will automatically fetch that kind of that operating system version. If you don't have one for that, then probably it will throw up an error.
Hi, just a quick question. You didn't cover it in the slides, but you can specify dependencies for your testing framework using
yes.
Things like test requires or something like that. I can't remember the exact
yes.
name.
So there is a test option too.
Yeah.
So I may not be.
Yeah.
I have not covered it. Yeah. So test is a command which you give to setup.py. So you can do tests there, and you can specify test dependencies here.
Yeah, you can specify test dependencies, but only for tests. And I think nowadays people are starting to use things like nose as more comprehensive test tools, so that it can leverage things like coverage and all these things. But there doesn't seem to be a way to specify dependencies for specific things like that I'm aware of. Do you know anything?
I'm not sure. I'm not sure about that, because I'm not dug deep into the newer ones, setup tools and like that. So if you do, if you're more interested in that, so probably you should go deep into the documentation of nose is a really good one. Wheel, probably.
Hi, Sanket. First of all, nice talk.
Thanks.
Okay. You're talking about external dependencies. Like there was a Django version. You're requiring this one. Can we package can we package this Django files, whatever it is, together so that the end user doesn't have to do all this behind work?
I'm not sure you should do that, because then what you're suggesting is, if I'm correct, what you're suggesting is you include a Django into your. So I'm not sure you should do that, because these projects, I mean, any project, any package would be there at pip, right? And people will install your packages through pip. Do they? Obviously they'll do that.
That's what we are doing here.
Yeah. So if you just specify your dependencies like that, pip will automatically do that. So if you really want to do that, I'm not sure, because I've not explored it. So there might be a way to do that, or you can do one more thing. You can just include that package in your distribution directory and distribute it as part of your package, something like that.
You want to anchor it to a particular version?
Not exactly. I just want it to be the installation to be done in one single step.
It will be done one step. Just put all versions as equal to, and you run PyPI install.
Yeah.
It will go with pip install. It will go and install everything else. And if you want the versions to be stable, just declare all versions as equal to.
Yeah.
Get exactly those versions.
So that is what I told you. That is what it was. Yeah.
Thank you.
This will be the last question.
Hey, hi there. Learned quite a few things from your talk. Thanks. So where we work, we kind of ship this desktop app that goes in schools, and that in schools you find everything from Windows 2000, XP, 2008. You even find Linux, Ubuntu, you name it. I mean, you got pretty much everything. So when we started in 2008, we didn't have anything of this sort. So we had custom scripts and all. One thing that I wanted to know, that there's this option you could generate RPMs and you could generate, so is there a way by which, I can first kind of test my RPMs, etc. against multiple platforms, rather than, have to set up my own virtual machines or something? Is there some kind of way?
Yes. Python allows you to, build cross-platform.
Okay.
So we have options for that, so that you can build on cross-platform. So if you don't have access to a machine, you can do it.
Okay. So is it possible? So MSI is the installer
Windows
for
installer,
Windows,
yeah.
correct? So
I don't think it's possible on Linux. I'm not sure, because I've not tried it. Is it possible? It's not possible. I mean, you need to have a Windows.
Okay. So one has to manually kind of install all of it and be sure it works. All right. Thanks. Thank you.
Thank you.
Thanks a lot, everyone.